Hi everyone, in this video we're going to be graphing piecewise functions. We're going to focus on linear functions today. So this first part was our warm-up. So if you missed class today or you needed to re-see it, I'm going to go over what we did for the warm-up. So we're going to evaluate, which is what we did the day before. So we have f of 5. That tells me when x equals 5. What is the y value? So we look at our piecewise, we find where 5 would fall, which would be in this middle section right here. And that means we're going to plug in 5 into 2x plus 5 for the x value. So we get 2 times 5 plus 5, which is 10 plus 5, which equals 15. So f of 5 is 15. Okay, looking at the next one, we have f of negative 2. That's what is the y value when x equals negative 2. So I look and I see that this top one right here does not have negative 2 included. This bottom or this middle one also does not have negative 2 included. So therefore there is not a point in this piecewise function where negative 2 has a value. So what we say is that this is undefined. Then we have f of 0. So what is the y value when x is 0? Well, that falls into that same highlighted one. So we would have 2 times 0 plus 5, which would be equal to 5. Now getting into the lesson part. We're going to first review the types of circles we have based on the inequality signs. So when you have an inequality sign with no line, then you get an open circle when you're graphing. When you have a line underneath, you have a closed circle, so it is filled in. Remember that our domain is our x values and our range is our y values. So if I'm looking at my first piecewise function, I have two pieces to it. What we need to understand is that our domain is this part right here. That is putting a restriction on the graph, and our range is actually going to be the equations. So when we do these, we need to pick some values to plug in. What I always suggest you do is you pick the values that are in the domain and then some values on either side of it. So if I'm trying to graph x plus 5, if x is less than negative 2, the first value I'm going to do is I'm going to find the y value when x is negative 2 for that top function. So even though it's not included at that point, because it does not have the line underneath, we still need to put a point there even if it's an open or closed circle. Okay, so I plug in negative 2. I have negative 2 plus 5. That gives me 3. So this gives me the point negative 2, 3. I'm going to graph it, but again, because there's no line underneath, it will be an open circle at negative 2, 3. Then you can either use the slope from the graph or from the equation, which is 1, and go up 1 over 1. But you have to make sure that you're only graphing when x values are less than negative 2. Or you pick another x value that is less than negative 2. Doesn't matter which x value, whichever one you want. So I'm just going to do when x is negative 3. I plug in negative 3 plus 5. That gives me negative 3 plus 5, which is 2. So I have the point negative 3, 2. I can plot that point right there. It doesn't have to be too big of a dot. And then all I have to do is connect the dots. If you want to find more points, you can find more points on the graph. But really you just need 2 points for a line. And today we're just focusing on linear functions with piecewise. Now I look at my next one. So now I'm going to graph this function right here. And this is when x is greater than or equal to negative 2. So I start by plugging in negative 2. Well, no matter what I plug in, my y value is always going to be 4. So I have the point negative 2, 4. But for this one, it is going to be a closed circle because it has an or equal to. And again, no matter what values I pick that are greater than or equal to negative 2, it's always going to be 4. So we get this horizontal line like that. And so that is what our piecewise function looks like for example number 1. Moving on to example number 2, graph the given piecewise function. So as a reminder, this is our domain restriction over here. This is our range. You start one by one. So I start by graphing the top function. The first x value I'm going to use is negative 1, but on this top equation, it's going to have an open circle. So when x is positive 1, I plug it in. I get 2 times 1 plus 2, plus 1. That would be 2 plus 1, which is 3. So I get the point of 1, 3. I'm going to plot that, 1, 3, making sure I do an open circle. Then I'm going to pick another x value that is less than 1. So I like to use 0 because it's usually the easiest number to work with. So we have 2 times 0 plus 1, which would be 0 plus 1. So that gives me the point of 0, 1. So I have this point down here. Now that I have 2 points, since I'm graphing a linear function, all I got to do is connect the dots. Then I go and graph my second equation of my piecewise function. So again, I start with the values in my domain restriction. This one also has an open circle because there is no line underneath. So when x equals 1, I have negative 2 times 1 plus 3, which is negative 2 plus 3, which is 1. So I have the point 1, comma 1. So again, I need to make sure that this is an open circle. Then I need to pick an x value that is greater than 1. It can be any x value greater than 1. I'm just going to go ahead and do 2. So I have negative 2 times 2 plus 3. That would be negative 4 plus 3, which is negative 1. So I get the point 2, negative 1. I go ahead and plot that point, and then I just connect the dots, and I make sure that I put arrows on them. Okay? And that's really all this is to graphing piecewise functions. So if you want to pause the video and try example 3 and then check your answer, do so now. So again, we're graphing a piecewise function. This tells us our domain. This tells us our range. You graph one by one. So I'm going to start by graphing this top equation. I start by plugging in negative 2. This time negative 2 is included, so it will, positive 2 is included, so it will get a closed circle. So at x equals 2, I have negative 2 times 2 minus 4. That would be negative 4 minus 4, which is negative 8. So at 2, I have a point at negative 8, and it is closed. Oops, that's not 2. 2, negative 8, and it's closed. Then I need to pick another x value that is less than 2. So let's go ahead and do 0. It never has to be the one directly next to it. It can be any point that you want it to be that is less than it. So I like to work with easier numbers, so 0 is an easy number to work with. So I have negative 2 times 0 minus 4. That would be 0 minus 4, which is negative 4. So it gives us the point of 0, negative 4. So 0, negative 4 is right here. I connect the dots, and it's going to look like that. Then I go ahead and graph my next function. So my bottom function, I have, again, I'm going to start with the value that is here, but it's going to have an open circle. So at x equals 2, I have 4 times 2 minus 9. 4 times 2 is 8, minus 9 is negative 1. So I have the point 2, negative 1 with an open circle. Then I pick another value. So let's go ahead and pick 4. I've randomly picked a number. You can pick any number you want. 4. So I would have 4 times 4 minus 9. That would be 16 minus 9. 16 minus 9 is 7. So I have the point 4, 7. So 4, 7 is about right there. We connect the two dots. And your piecewise function would look something like that. So hopefully you got that. If you picked x equals 3, that would be 12 minus 9, which is 3, so you'd get the point 3, 3. And if you look, our graph does go through that point right there. Okay, last one, graphing. This time we have 3 equations. Okay, so same concept. Now we just have 3 parts to it. So I'm going to start by graphing this first function right here. So I'm going to start with negative 2. Negative 2 will get a closed circle because it's a line underneath. So I get negative 2 minus 1, which is negative 3. So I get the point negative 2, negative 3. So negative 2, negative 3 is right here. Again, it gets a closed circle. I'm going to pick one more value that is less than negative 2. So this time, let's pick negative 5. So we have negative 5 minus 1, which is negative 6. So it's negative 5, negative 6 as a point. So negative 5, negative 6 right there. Connect the two dots. And it looks something like that. Now I go to the middle piece. Okay, so for this middle piece, I'm going to plug in 2 and I'm going to plug in 4. 2 has an open circle, 4 gets a closed circle. So that's how I pick the points to use when there's 2 endpoints, or if it's a middle function like this one. So I have x equals negative 2. Again, it's going to get an open circle. So that would be 2 times negative 2 minus 1, which would be negative 4 minus 1, which is negative 5. So we get negative 2, negative 5. So I go negative 2, negative 5. It's an open circle. Then I'm going to pick 4. So I get 2 times 4 minus 1, which would be 8 minus 1, which is 7. So I get the point 4, 7. So I go over 4, up 7. That one gets a closed circle. And then I connect those 2 points. Like that. Lastly, I'm going to graph this last equation right here. I'm going to start at 4, making sure that I give it an open circle. So I have negative 3 times 8. Oh, sorry, not negative 3 times 8. Negative 3 times 4 plus 8. There we go. That is negative 12. Negative 12 plus 8 is 4. So that is the point 4, 4. Again, making sure it has an open circle at 4, 4. There we go. And then any random point, so let's just go ahead and do 5. That would be negative 3 times 5, which, negative 3 times 5 plus 8. That would be negative 15 plus 8, and that would give us negative 7. And I just realized that I did graph that last point wrong, so I'm hoping y'all caught my mistake. Negative 12 plus 8 is negative 4, not positive 4. So that point should have been 4, negative 4. So hopefully you caught that mistake that I made. And then the one we just had was 5, -7. So 4, -4 is right here. And 5, -7 is right here. Oops, that was -6. One more down. Right there. So the graph should look something like this. Okay, so if you have any questions with graphing a piecewise function that's linear, please make sure you ask. Again, the more you do, the better you'll get at it, and write down any questions you have so you can ask your teacher the next time you see them, and I'll see you in the next video.